So today's topic is dealing with the sensory organs. So we're going to look at the first one, which is the tongue. Now, your upper surface of your tongue, you know for a fact your tongue does bring the sensations for you to be able to taste things, right? Now, it has taste buds. The taste buds are the tiny bumps that are on your tongue. It's actually all over your tongue, and it has little sensory cells that could pick up the chemicals in food, right? So your mouth does have saliva in it, keeping it moist. And when the chemicals from food dissolve in that saliva, you are able to have a taste, right? You can taste things. So different parts of your mouth can pick up different types of taste. Some parts can pick up sweet, some picking up sour, bitter, and salty. Sweet, sour, bitter, and salty are the different tastes that we can process. Our nose, right, is responsible for us being able to smell things, right? So there is a group of cells that are to the top of your nose that is known as the olfactory organs. That as well can pick up the chemicals in the air. The only thing is scent is rapidly deteriorated. So you don't really smell something. The sensation of smell doesn't really last for very long. It's very shortly received, I should say. All right. From there today, our main focus is going to be on the eye. We're going to look at the parts of the eye, how it adjusts to be able to see light, and objects that are near and objects that are far. Anybody have any questions there for me, or are we good there so far? You can leave a thumbs up if you're fine. Asishana, Brianna, Chiron, Mateo, Abdul. Right. So we're taking down here. And when we finish, I'll scroll down to the nose, and then we're going to go to the eyes. So we'll look at the parts that actually do for protection, and then we'll look at the parts that are responsible for vision. So let me know when you are finished. All you know that if it is your eye is aware that, sorry, your immune system is aware that you have eyes, it would attack it. You ever hear about that? Anybody? Did they say that if it is your immune system knows that you have eyes, it will attack them? So your immune system actually doesn't know that you have eyes. Yep. So when we look at objects, we are looking at light reflected from them. And in our eye, the optic nerve, there is an image that will build up. The impulses will send the nerve impulses will go to the brain will coordinate all of this information from the objects to be able for it to be able to see. Right? Now, there are parts of the eye that are very delicate that requires a certain level of additional protection. We have the orbits, which is the eye socket, which protects the back 3/4 of the eye. So it's only a quarter of your eye that you actually see that's at the outside. The rest of it is protected well inside of your eye socket or orbit. You have your eyelids, upper and lower. This is necessary to protect the eye against dust and bright light. Blinking as well is really important to help prevent dust from going into the eye and to spread tears when your tear glands make them. Pen one boy. Right. The eyelashes are important because they will trap dust that will be present in the air. It traps it near the eye. So that's why when you're washing your face, especially, you wash your eyelashes, right? Sometimes when you find that it getting itchy is because too much dust is accumulating in the lashes. The conjunctiva is it's a continuous piece of tissue that starts in the top eyelid and goes down to the bottom. That is to protect your cornea from scratching because your cornea is responsible for bending, right? Bending of the light rays. And then we have the tear glands. Your tear glands actually secrete tears. And in the tears is a powerful enzyme that is called lysosome. Again, things will land into our eye. Sometimes we don't know. It happens. And preventing that from making sure that the bacteria doesn't invade the eye, the tear gland, the lysosome actually destroys the bacteria and then it drains into the inner corners of your eye. Right? So we take it down this here and then we're going to go through the anatomy of the eye next. Books are swollen down, right? Swollen down into tear glands. I just want to use the washroom. I'll be right back. We're gonna get down into the structure of the eye, the longitudinal section of the eye. Um, Now, personally, this is something that I usually see more in the multiple choice, this particular question, right? Or this particular diagram, I should say. I've not seen in the recent papers you having to draw this. But I mean, knowing the parts will not hurt, right? Knowing the functions wouldn't hurt. Knowing how to draw it wouldn't hurt as well. So here, let's go with it, right? So the white part of your eye that is visible to you is known as the sclera, right? So it's a tough white fibrous coat, and the purpose of it is to protect your eyeball. The layer underneath that is called the choroid. So it's usually black in color, and the purpose is to prevent internal reflection of light in the eye. So you don't want the light just dispersed all over the place. You want it to focus directly onto the retina, right? So the choroid will prevent that from happening. And it also have like all of the blood vessels inside of the eye that is going to supply your retina, which is your photosensitive layer, with the food and the oxygen. Tell me if we got there so far. Give me a little thumbs up if we cool. Abdul? All right. Cornea. Now that's the front part of the eye. So there's the transparent part of the sclera, the white part. And the cornea actually does the majority of the bending for light so that when it actually hits, so this is where your cornea is, when it actually hits your lens, it's just like a little minor adjustments is being made to focus the light directly onto this point here, which is the retina. The colored part of your eye is called the iris. It's composed of muscle and it will adjust its size. The purpose is to prevent light from entering in all directions. You want it to concentrate straight into your pupil, right? So your pupil is the hole in the center of your eye, right? Center of the iris. So the black hole, right? In the pupil, this is where light will enter the eye. Now your pupil does do reflexes to be able to manage the amount of light that entering and at the eye at any point of time, right? I want to get a video to show you the pupil reflex because again, these are things that you need to know as well. So it basically is when it says your eyes are in bright light, it will get smaller to to kind of want to find the right adjective. It gets smaller to restrict the amount of light entering the eyes. You know, because when you're in bright light, it could run the risk of damaging your retina. So your pupil's gonna make that little adjustment to minimize how much light gonna enter. If you are in darkness, your pupil or dim lighting, your pupils will get larger to be able to allow as much light in as possible for you to be able to see, right? So here we go with what it looks like. I mean, and you could try it if you have siblings. You could try this on them when so when you're done class. Just don't go flashing light in the eye just so, right? Please and thank you. Pupil. That's your pupil reflex that you was just watching there, right? Anybody have any questions based on what they've seen so far? All right, going back to the eye. So when light passes through the pupil and it passed through the cornea, it had to hit the lens, right? Now, if you look at your lens, we call your lens a biconcave structure. Sorry, convex. Convex is outside. Concave is inside, convex is outside. It's biconvex because it's curved on two sides. It's elastic because it can adjust its size. And the purpose of your lens is to be able to make these little minor adjustments to focus the light coming from different objects for your retina. So your lens helps you to see objects that are near, objects that are far. Your suspensory ligament and your ciliary muscle. Let me just plug on my laptop there before we conk out. Right. Suspensory ligament and the ciliary muscle and the ciliary body, they work hand in hand with each other to be able to make adjustments of the lens. They work antagonistically, so opposite to each other, to be able to allow the lens get bigger or smaller depending on what you are viewing. Tell me if we are okay so far. Anybody have any questions? Give me a thumbs up if we're okay, right? Right? So let me talk about your retina now. So your retina is the most important part of your eye. Or I should say most integral part of your eye, right? So your retina is the photosensitive layer. So that is your retina there represented in this diagram, right? So this is the part where light will fall on to generate a nervous impulse for your brain to be able to pick it up, for you to be able to see, right? Hold on a second. Right. So your retina have these photoreceptors concentrated in different parts of your eye. It allows you to see in dim lighting or dark lighting, and it also allows you to see in colors. So you could be able to see in black and white, and you can be able to see in colors because of the two different types of receptor cells in the eye known as the rods and the cones, which we're going to talk about after. There is one part of the eye that is known as the fovea that has the majority of the cones there. That's the most sensitive part of your eye. So once your light falls here properly, you can see clearly. The closer the receptor cells are in the eye, the clearer the image that will be created. All right? Tell me if we okay there so far. All right. Then we have the optic nerve, right? So the optic nerve will take all of these impulses that come in from the retina and carry it to the brain. But there is a spot just where the optic nerve leaving the eye, this location right over here, which is known as the blind spot. If have no photoreceptor cells there. So if light fall on any part over here in the blind spot region, no image is going to be formed. So you're not going to see nothing. Hence the name blind spot. We have the aqueous and the vitreous humors. Those are responsible for helping support the eye and give it its structure, right? So with that being said now, we're going to go into the retina a little more in detail, and we're going to look at image formation as well. Now, your retina is located to the back of the eye, right? And there are two types of cells that I mentioned, the rods, which will allow you to see in the dim light, and the cones, that will allow you to see in bright light. Check something out, man. Tell me if it is you agree with this, right? It's nighttime. Current cut off. When the current or the electricity now go and everything around you just be pitch black and it can't see nothing, tell me if it is you know what I'm talking about. If that ever happened to you. Electricity now gone, everything pitch black in the night. But after some time, you start to see the outline of the objects around you. Tell me if that's a yes or a no. So you could be able to see where your bed is, the TV is, your wardrobe is, right? You might be able to see all of those things, right? No. The thing is, your rods are responsible for you to be able to see that, right? Now, you're not going to see the color of these things because the rod cells does not allow you to see in color. You're only going to be able to see the outline of it, which is in black and white, right? But no color at all, right? However, when you're in bright lighted, you're going to see color all your objects around you and in real detail and all too, right? And it's because your cones allow you to see in color, all right? So once the light falls on that receptor cell, that cell now is going to generate an electrical impulse that's going to go to the optic nerve, brain is going to take it, and it's going to take all of these messages that are coming in from all of the receptor cells in the eye, and then it's going to build up an image. The closer the receptors are, the clearer the image that is formed. Tell me if we're good there so far. The eye is such a wonderful thing, but you just have to make sure you treat your eyes well because it's easy for damages to occur and it's easy to lose your vision, right? So I'm going to play you a video to show you how your eyes work, how the retina works, right? Because in your eyes, your image on your retina is formed upside down. It's your brain that is oriented right side up. So we want to see how that process occurs, right? Here we go.
Light rays enter the eye through the cornea, pupil, and lens. These light rays are focused on the retina, the light-sensitive tissue lining the back of the eye. The retina sends signals through the optic nerve to the brain, where these signals become the images we see.
All right. So that's a little breakdown there with the eye. Anybody have any questions there so far, or you think you guys are okay there so far? All right. So I will leave the diagram for you to take down for homework, right? I'm gonna give you the functions of the parts. We're gonna go through the how the retina image formation on the retina. And when you're finished there, I want to do accommodation. I'll tell you. That particular topic, accommodation, actually comes majority of the time for your exams, right? And it's so simple, yet kids misunderstand how to apply the information for accommodation. It's real simple. So I want to give all of the points and go through accommodation today, at least with you all. All right. So please let me know when you are finished here.